Okay, kids, welcome to complex circuits. That's right, complex circuits. I know some of you think, well, weren't those last ones really complex? No, those are called combination circuits. Those are fun. Those are puzzles to solve. And sometimes you have to come up with strategies and methods to solve them, which makes them more fun. This is complex circuitry. Oh no, don't panic. Some of you will actually like complex circuits better than combination circuits. I don't think so. You might, because there are actually rules that you follow, steps that you follow to solve them. So they ain't so bad. Like Mr. T in Rocket 3, you ain't so bad, you ain't so bad. Yeah. So here we have a complex circuit. What makes a complex circuit complex? Well, here's what you got. You got several lines. Well, that's not nothing new. Yeah, but we also have power sources on different lines. Okay, the power sources here, it's not like batteries. We only had them in one area of the circuit before. Now, when you put them on different lines, it becomes a little more complex, hence complex circuits. All right, so we're going to solve these by, and what we're going to solve for, the thing we're trying to solve for is the current. How much current goes through each one of the three lines? There are three lines here, makes a pride. Pride of lines, funny. And we have line 1, line 2, line 3, call it whatever you want. What I like about the complex circuits is you can make up symbols and call them whatever you want and then solve accordingly. No matter how you solve your complex circuit, if you do it right, if you follow the rules, you should come out with the right answers, just like anybody else who might have done it differently. Okay, here's what I'm talking about. First thing you're going to do is you're going to figure out the current that goes through that line, that line, that line. 3 different currents, most likely. I mean, I suppose there's a small chance it'd be the same, but probably not. So what you do is you label these currents. Let's use a different color here. Well, 3 of them. So I is current. I1, I2, I3. Okay, all right. So I'm just cracking myself up. Okay, here's what I'm going to do. I'm going to do. I am going to give this current up here, I'm going to call this current going around like this I1. And I'm going to call this current down here on this line I2. Now, here's the thing. And I'll call this one I3. I'll call the current through this line is I3. So there's my I3. Now, if I wanted to, this is America. Turn you this way. You kids need to be over here now. Okay, focus. So you could call this line I1, you can call this line I2, or this line I3, it doesn't matter. You can call this line I3, this line I2, this line I1, it doesn't matter. I decided to call this one I1, this one I2, and this one I3, because I wanted to. Now here's the other thing. I put arrows in directions. How do I know that the current's going in that direction? No, don't try to figure it out from here, because it can get kind of complicated, okay? I mean, you might be able to figure that out. And actually, I did put this current going in this direction, this current going in this direction. I mean, looking at the batteries, maybe I'm right, but we don't know that. So it doesn't matter. Just pick a direction. What? Wait a minute, time out. You said I can make these I's, any I want. I mean, you can. I mean, you don't even have to make them I1, I2, and I3. You can make them I20, I30, and I40. If you want, you're going to follow these rules, you'll get the same answer. Is anybody else setting it up any other way? Now, I also chose the current to go this way, and this way through my chosen I's. Now, I could be wrong. I could be wrong. We'll find out, because once we follow the rules, we will find out not only what the value for these currents along these lines is, but we'll also find out if the direction that I just arbitrarily chose is right or wrong. Okay, we will find that all out. Oh, it's going to be fun, kids. It'll be fun. Okay, so here's what we do. What we're going to do is, the first thing I'm going to do is write, oh, I should have put this up here. I can still put it up here. Here, I'm going to put this over here. Maybe you kids should take this down. Get you in close here. There we go. I got a mess here. Okay, those are some rules we're going to follow. Maybe take a screenshot. I don't know. Oh, but put this one in first. I have to do this one. Make overall I equation. Make overall I equation. And then we're going to do bump, 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 bump. This isn't going to make any sense to you right now. No, it's not, but it will. Nice, got that screenshotted? Okay, because I'm gonna move this back over. Okay, so here we go. So we're gonna make an overall equation that represents a flow around the circuit. Oh, you kids are real close. There we go. Get you back there. Oh, I got a mess here. Still snowing out, even heavier. I gotta go clean up. It's gonna be an interesting drive home. Okay, so now what I have is I have this current coming down this middle line. See it? I had it going to the left, and it splits. It splits. So what would be true? Let's make an equation that represents the I's that would represent the overall flow. And that would say that, okay, the overall, then I3, in the way I set this